Okay, welcome back to College Algebra. This is the correction video for assignment number 2. In this assignment, we focus on drilling how to all the concept related to all the concept of a circle of equation, standard form, general form. Focus on drilling how to find the domain of the function. All the formula such as midpoint formula, a distance formula. Let's get started with the first one. So on the first question, I want you to determine some given point if it forms the vertices of the right triangle or isosceles triangle or not. And this problem kind of similar to one of the example I have in the lecture note. Okay, so in order to do this one, you just need to open the lecture note and see the example, and I give you 3 points. A is tan phi, B is 3, 2, okay, and C is 6, negative 5. And I ask you if these 3 vertices ABC here will be forming vertices of the right triangle or not, or isosceles triangle. If you guys know that if it is isosceles triangle, we know 2 sides congruent to each other. Okay, so in order to show if it is the vertices of isosceles, we just need to show 2 sides congruent to each other using the distance formula. And for the right triangle, as long as satisfy the Pythagorean theorem, then it will be the right triangle. Okay, so let's see which triangle it will be. Alright, so first of all, I want to find the distance between A and B. Okay, and we're going to use distance formula, x2 minus x1 square minus a2 minus y2 plus y2 minus y1 square. Okay, minus y1 square. Okay, and this is give you square root of 58. Okay, that's AB. And BC, you do the same thing, and it gives you square root of 59 also. Okay, and I calculate CA using the same formula, and it gives me square root 116. So you see that if it is if it create a right triangle, then it satisfies Pythagorean theorem, and Pythagorean theorem is a squared plus b squared equals c squared. And let's see if it satisfies these 3 number here. We plug it in here and it's satisfied equal to each other or not. So AB is 58 square plus BC is 59 square, and give you 116 square or not. Okay, this is I throw away 58 plus 59. Do you think so? And this is 116. So this not right, because 58 plus 59 oh, there's something wrong over here. Okay, 58 plus 59 is not equal to 116, so it does not create a right triangle. So it create oh, let me see, did it create any it should, I think I have some kind of mistake, because over here it will not create isosceles triangle either. So oh, right, it's 58, right? It's 58 here. I'm sorry. Here you go. So they're equal to each other, because 9 plus 49 is 58. It's not 59. I'm sorry. So I squared it. 58 plus 58 is 116. Okay, then equal to 116 right here. So it satisfies the Pythagorean theorem. Okay, then it forms a right triangle. Okay, so that is for number 1. On number 2, I give you the general form of standard of equation. The general form of equation of circle, I'm sorry, and I want to convert this general form to standard form. And the method, the strategy to do this is that we have to use completing the square. Okay, we have to do complete the square method to convert between general form to standard form. We know that in order to convert to standard form, we need to bring this general form right here given to the form x minus h squared plus y minus k squared equal to r squared. This is the standard form of equation of circle. And I'm gonna go ahead and using completing the square concept to bring this to the perfect square form. Okay, so first of all, I'm gonna group all the term with x together. Okay, 16/5. The number kind of big, and I kick the number 3 to the other side. So I take this, I divide by 2, right? I take this, I divide by 2, give you what? Give you 12/10. Then I square it, give you 144/100. Add 144/100. The same thing over here. 16/10 square is 100. 16 squared 256/100. And I have 256/100 here. Okay. Then the first 3 term here will create the perfect square, and the last 3 term here it also create a perfect square. Okay. And I add these 3 number here. It gives you very wonderful number, 100/100 equal 1. So now I see that it's in the standard form already, which h is 12/10 and k is -16/10. Then the vertex will be the center. I'm sorry, the center will be 12/10, comma -16/10. Okay, and radius will be 1. Okay, radius will be 1 right here. Alright, let me check this a little bit. Okay, alright. For problem number 3, so problem number 3 focus on drilling how to find the domain of the function. Okay, and I give you about how many functions? 1, 2, 3, 4, 5, 6, 7, 8. I give you 8 functions, and I want you to find the domain. So the first function is f of x equal to square root of x plus 3 over 2x minus 1. And I say how the time that in order to find the domain, you have to consider the bottom and the top. Okay. And I say that the bottom cannot be 0, so we need to find the value that the function will be 0 at the bottom. So the value will be what? So the domain will be everything except for that value, because we're not allowed to have 0 at the bottom, and not the value that has 0. When you replace x with that value, if you 0 will be 1/2, right? So the domain will be everything else except for 1/2. Okay, and on the top, you know, we cannot take square root of negative number, so everything inside must be greater than 0. Okay, so I'm gonna write interval notation for this. Okay, so the final domain will be what? Will be everything is greater than -3, but must be different from half. So the domain will be what? The domain will be including -3 to a half, parenthesis, union parenthesis, 1/2 to infinity, because everything else except for a half. Okay, if you guys cannot get into the answer right away, you guys can just draw the number line like this, and this, we know this is -3 here and 1/2 here. We want to include it, but we don't want to include a half. Okay, so it will be over here. Okay, because we want everything greater than -3 and different from a half. Okay, so that's the solution for part A. For function B, for function B, I realized that the top, there's no radical, so we don't have to consider the top. We just need to consider the bottom. So again, the bottom cannot be 0, so I'm gonna write it x minus 3 and 2x minus 1 cannot be equal 0. Okay, cannot be equal 0. So because if it is 0, then cannot be bottom, so it cannot be equal 0. And I apply the 0 property. I have this, and I solve for the x value 1 over 2. Oh, okay. And what else? Excuse me. So x different from a half, and however, this is a radical. We are not allowed to have a negative number inside a radical, and we're not allowed to have 0 inside the radical. So we also have to include 2x minus 1 greater than 0. So x must be greater than a half. Okay. So we want everything's greater than, we want everything else except for 3. We want everything else except for 1. Okay, but we also have it greater than a half. Greater than a half. So our answer will be what? Will be greater than half, but not including half. So it will be parentheses greater than a half to 3, right? Union with 3 to infinity. Okay. So this will be the domain. Because we don't want 3. Okay, we want everything else, but everything else must be greater than half, because we cannot take square root of negative, so it must be the radical must be greater than 0, and we want to do everything greater than 3 also. Okay. C. Okay, so for C, the function that look like this. Oh, on the top we have radical now, so we have to put it into consideration. The bottom we have x squared plus 4. Okay. Okay, so we have to analyze a little bit over here. So you know that the top has radical, so x must be greater than -2. Okay, because if it's less than -2, then we cannot take square root. Okay, it cannot be 0, because if it's 0, the whole bottom is 0. We're not allowed to have 0 in the denominator. X squared plus 4. Just think about x squared is a positive number, right? We square any number, give you a positive number. You add another positive number, give you another positive. You take square root of that positive, give you the final positive number. So square root of x squared plus 4 always makes sense, no matter what value of x you plug it in here. So we don't have to put into consideration. Okay, we can just we can write like that. So this does not matter, because this is always true. Okay, so we just consider these two domain right here, so we want everything greater than -2 and different from 0. So the final will be -2, 0, union with 0 infinity. Okay. That is for C. And for D, let's see. For D, so I had a function like this with absolute inside a radical. Okay, at the bottom I have like this. So you see that the bottom has is a trinomial form, is quadratic form. So I'm gonna just go ahead and factor them. Sorry. So I factor them. So x plus 1, x plus 3. And again, we have to consider the top, because in this case, it's out of focus. I'm sorry, guys. Let me refocus that. Or maybe I should change the pen. You know, this pen is not really good. Let's use different color. So on the top we have radical, so we have to consider that. Into the domain, the bottom again, we do the same thing. We're not allowed to have 0 at the bottom. So we're going to set everything different from 0 for the bottom. So we have x plus 1, x plus 3 different from 0. Okay, because we're not allowed to have that, so apply 0 property. 0, this is different from 0, x plus 3 different from 0, so x different from -1, x different from -3. So as long as it's different from -1 and -3, then there will be domain. The rest will be domain except for this and this. Now let's consider the top. Again, this is radical, so the radical cannot be negative, so everything must be greater than equal to 0. Okay, so this is absolute inequality. So I have what? I'm going to just go ahead, I subtract both sides by 5, and I divide both sides by 3. I change the sign. So this is absolute inequality. You guys are supposed to memorize the formula. Okay, this is absolute of A less than B. So A less than B is less than A, negative B less than A less than B. So the domain of this part only will be -5/3. But we have to combine with the domain here. So the final domain will be what? Will be everything else except for -1 and 3, but must be include we must include this domain also, must be between -5/3. So if you put on the number line, I have a -5 over here, -3 here, -1 here, 5/3 here, right? So we don't want -1 and -3, and we want between this and this. Okay, so the domain will be what? Will be -5, -3, parenthesis, -3, -1, union -1, 5/3. Okay. It should be. Okay, it should be. Okay. 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 So in my solution there's some mistake, so I wanted to fix that a little bit. Alright, so that is for D. Okay, that's for D. Now let's do E. It's very easy. It's very easy because we don't have to consider the top. There's no radical on the top. And if you look at carefully, the bottom, you see, the bottom here is square root. Okay, the bottom is not allowed to have 0, and you see that x squared plus 2 is always greater than 0. This is true all the time. True always. Okay, it's true always. Because no matter what value of x you plug in here, it's always greater than 0. So the bottom is never, it will never be 0. Okay, no matter what value of x you in here. So no matter what value of x you plug into the x, is all the function always defined. Okay, so this function, the fx function here always define whatever the value of x you plug it in, positive or negative, is always give you the output. So the domain will be all real number. Or you can write negative infinity to positive. You can write this also, okay? Because this symbol means all real number. You're supposed to know this in the first chapter of the textbook. We call the preview chapter. Okay, and I want you to read that chapter. I don't know if you guys have time for that or not, but you should read it. Okay. That is for E. Okay, that's for E. How about F? Yep, I give you the function like this. Again, on the top we don't have radical, we don't have to consider that. At the bottom I have this. The reason I told you to fix the question because this is much easier than the previous version. Okay. So in order to do this, again, I consider the bottom. Okay, I consider the bottom, and the bottom right now is kind of messy, so I want to simplify this. So I expand this. I use a perfect square formula, so I give you x to the 4 minus 2x squared plus 1 minus 2x squared plus 3. Okay, so give x to the 4 minus 4x squared plus 4. This is another quadratic right here, guys. You guys can factor this also. If you guys factor this, give you x squared 2 negative 2 negative 2. Okay, and I already told you we're not allowed to have 0 at the bottom, so everything must be greater than 0. Okay, and we can write this as this, different from 0. I take square root, so we give this being different from 0, and I can solve for x different from 2. X must be different from plus minus square root of 2. So what does mean that as long as it's different from plus and square root, plus minus square root of 2, everything else will be domain. So the domain will be what? The domain will be negative infinity to negative 2 square root union with negative square root 2 square root 2, right? Union with square root of 2 positive infinity. Okay, that will be the domain. G. Okay, G that look like this. I have x over x minus square root of x minus 6. I know it's finding domain is hard, but you guys have to train your brain to think critically. Finding the domain was out the way of training your brain how to think logically. Okay. Again, on the top we don't have radicals, so we don't have to consider the top. We just need to consider the bottom, and I said 100 times already, the bottom cannot be 0, so it cannot be like this. So I have x minus 6 cannot be square root of x, so square root of x different from x minus 6, so x is different from x minus 6 squared, which is x squared minus 12x plus 36. I cancel this, so I have 12x is different from 36, x is different from 3. Alright. Oh, I cannot. I'm sorry. I cannot cancel it because it's this is not a square. Let me redo this. So I square this to give you x different from x squared minus 12x plus 36. So I combine that term over, so I have x squared minus 13x plus 36. So this one is factor this trinomial. So I'll give you what? Give you negative 9. X in negative 4 is different from 0. So x much different from 9 is x different from 4. Okay, so the domain will be everything else except for 9 and 4. However, they have radical under the bottom here, so we're not allowed to have we're not allowed to have negative under the radical. Okay, because with under the radical here you cannot take square root. So we have to include x must be greater than 0 also. Okay, x must be greater than, because there's an x in here. So everything else except for 9 and 4 must be greater than 0. So the final answer domain will be what? Must be greater than 0, but not allowed to have 0. So it will be parentheses, I'm sorry, because we don't want to include 0, 0 to 4, parentheses, union 4, 9, parentheses, union 9, infinity. Alright, that will be the domain of G. Okay, it's kind of a little bit complicating. I don't know if I have any kind of mistake, but the logic should be correct. One of the students in class, remember I showed you how to do this, and one of the students in class realized the square root of x, which I missed. I remember. So that's good. That was good. You know, we had to consider because the radical at the bottom. Okay, that is for G. Or maybe yes, that's for G. Now let's do the F. Let's do the H. The H, I have function like this. I have square root negative 2x plus 3. So we have radical on the top. We have to consider that. We have also radical at the bottom. We have to consider that too. We have to consider the whole denominator. Okay. So let's consider the top first. As I already told you, the radical cannot be negative, so everything inside must be greater than 0. Equal to 0, so I have negative 3x greater than negative 3. X must be less than equal to 3 over 2. So the domain will be everything else will be everything less than 3 over 2. So for the bottom, everything must be different from 0, because we're not allowed to have 0. So I have 3 square root x different from x plus 2, and I square both sides. So I have 9x different from x squared plus 4x plus 4. So I have x squared minus 5x plus 4 different from 0. I factor this. So I have x minus 1, x minus 4 different from 0. So x different from 1, x different from 4. Okay. So the domain in this, the bottom will be everything else except for 1 and 4, but we have to consider square root of x again, a radical of x, because we're not allowed to have the negative number here, so we have to include that x must be greater than 0 also. So what we have here is we have on the number line we have what? On the number line we have 3 over 2, so we have 1 here, 3 over 2 here, we have 4 over here, and we have a greater than 0 here. Okay, we don't want to include it. We don't want to include 1, 4. We want to include 3 over 2, but it must be less than 3 over 2. Less than 3 over 2, greater than 0, different from 1 and 4. So we have to combine all these 3 conditions together. So my domain will be what? Greater than 0, right? But not included, so it could be 0, different from 1, so 0 to 1, parenthesis 1 to 3 over 2. We want to include 3 over 2. We want 1 less than 3 over 2, but greater than 0, so basically like this. Okay. We don't want to consider this because we don't want everything greater than 3 over 2. We want it less than, so we cannot consider this part right here. So that everything domain will be everything inside here only. Okay, so we want greater than 0 but must be less than equal to 3 over 2. If it is greater than, it doesn't work. So this will be our domain. Okay. Alright, again, in order to master finding the domain of the function, you have to do a lot of function, and this is one of It's only a problem. On a real test, I give you pretty easy, just easier than this. But just think about if you aim high, you know how to do this. The easy one should be you should be very okay for the easy one. Let me know if I have any kind of mistake. But I don't think so. The logic should be alright. Again, I'm very happy that one of the students recognized the square root of x here, so I want to include x must be greater than 0, okay? Because if it is 0, if it is less than 0, we cannot take square root of negative value. That is very good, you know. That student deserve 2 points in my test, okay? Okay, deserve 2, but it's 2 extra points, you know, because not a lot of people can realize that. I missed that too. I forgot that. Okay. Yeah, so please let me know if you have any question. You can find any error, let me know also. If you can find any error in my solution, I probably add you 1 point in the next test, okay, or on the first test. Just let me know. So go ahead, take your time and watch the video of the correction, and have a good day, and I'll see you next time. Bye bye.